All right, so the first couple sections on your review and on your test are repeated sections, and I'm hoping this is the last time we have to test these. The inverse function for this one. Remember, your first step to finding inverses is to switch your x and y. So this is really a y. So when we switch it to x and y, it becomes x equals 3y minus 7 over 2y plus 1. And then we have the added issue of there's so many y's in the problem right now, and they're not even on the same side of the equal sign, and they're also stuck in a fraction. So you are going to cross multiply this fraction, or work up here now. So that becomes 2xy plus x equals 3y minus 7. And then your job is to solve for y. The problem is there's still too many y's in the problem. They're not even together. So you're going to move all the y terms to one side. I'm going to move the 3y yonder and the x over here. So that gives me 2xy minus 3y equals what? Negative x minus 7. And then you still have an issue of having too many y's in the question. So over here, now that they're all collected, you can factor out that common y. And when you do that, you have the quantity 2x minus 3. And then you're almost home free. You guys know you're supposed to divide by 2x minus 3. The only challenge I have for you is what do you name the inverse of this function? F inverse. Very good. So F inverse of x is negative x minus 7 over 2x minus 3. There we go. Actually, that was a question y'all did very well on. Number 2 was the question on the last test that bamboozled a few of you. How do you know if a function is one-to-one? Through looking at it. It's going to have to pass the vertical line test and the horizontal line test. So this little curve they have sketched here does pass both the horizontal and the vertical line test. So we're going to say, yes, this is a one-to-one function. And then this last question in the inverse section, I'm actually going to go to the next screen because it's got a bigger graph. They want you to find the inverse of g, and they want you to graph both the original and the inverse on the same coordinate plane. So we should see some symmetry. Excuse me. It's up to you how you approach this question, but just knowing what I know about how you guys typically approach this question, most of you will choose to find the inverse first. So you will switch the x and y around. And then you will solve for y by adding 6 and then dividing everything by a 2. Now, because you're going to have to graph it in a minute, instead of doing like the whole quantity divided by 2, it would make more sense if you just divide each term by 2. So 1/2 x plus 3 is going to be your inverse for g. So now they want you to graph both the original graph, which is, what, 2x minus 6. All right. 1, 2, 3, 4, 5, 6. This is very small, so I'm not sure if I'm counting right. Then slope of 2. And then look what cool feature my co-teacher taught me. I have a shape tool. Oops, helps if I could actually draw. But it magically created a line. Wasn't that nice? All right, and then this other one, 1/2 x plus 3, the inverse that you just found, has a y-intercept at 3 with a slope of up 1 over 2, or down 1 left 2. Okay, good enough. And then this is what I'm looking for, guys. If they are inverses of each other, they should be reflections across the line y equals x. Now, obviously I didn't graph really well, but if you squint, they kind of do appear to be reflections. The other component for inverses, remember the ordered pairs flip-flop? So for instance, this ordered pair right here, which I see as 3, 0, should have a partner of 0, 3 in the other function, which it does right there. So those are all good ways to verify and double check that you've graphed the original and the inverse and they're appropriate. But the difference is on your last test, I didn't give you a function, I just gave you ordered pairs. This time I'm giving you a function. So if you choose to find the inverse through just switching x and y like normal, that's fine. But you do need to know to be looking for that symmetry across the line y equals x. All right, this next one, -2 cube root of x minus 1 quantity squared. Yes. Yeah, that might be a good idea. You guys might want to, in case something goes awry, you might want to come through and label this guy as g of x, and then this blue one here as inverse of g of x. So that way, like, if you got the right inverse function, but you plotted something weird, I could at least give you some feedback as to what went wrong and maybe not like devastate your grade. All right, next section. Get that typed in your calculator, please. So when you get this graphed, if I remember correctly from last hour, it looks something like this. I don't know exactly what it looks like, but something like that. And your calculator, of course, doesn't show you the arrows. You just have to know the continuation of the function because of the nature of the function. It's going to go forever left and right for domain. What about range? It starts at negative infinity. Where does range stop? What's the highest y value it reaches? 0. Now, some of you are struggling with whether to use an ordered, like a bracket or a parenthesis here. It does hit a point at y equals 0, so you need to use a bracket. And this is where math textbooks have a great debate over the X-Intercept question. We have to decide whether you want to call that an X-Intercept. Turns out even your math teachers in this building will disagree on this concept. This is not, in your book's opinion, an X-Intercept. It is a solution and it is a 0 to the function. But in order to be considered an X-Intercept, it would have to go from positive output values to negative output values, so it would have to cross through the axes. So, in my opinion, it's totally acceptable to say none in that case. But if you claim that you're going to call 1, 0 an X-Intercept, we will accept that. It's a great debate in math. Now the y-intercept, there's no debate on that one, guys. You can easily see that there is a place where it crosses through the y-axis. On your calculator, the easiest way to find that is to hit trace and then plug in a 0 by hitting x equals 0. And it'll pop out to -2. They're not always pretty numbers, guys, so you might want to use that trace feature. End behavior. End behavior, you have to know the template, and then you're going to fill it in. So f of x approaches something as x's go to the left, and f of x approaches something as x's go to the right. Now, regardless of which side you're looking at, I can tell that both of the ends are traveling downwards, so both end behaviors are approaching negative infinity. Just make sure you guys are being careful about this part of the end behavior. I've had a few of you like put the same thing for both of these x parts. Well, end behavior is referring to the left end and the right end as separate ends, so you got to make sure one's positive infinity, one's negative infinity. And then is it continuous? There's no hole, there's no gap, there's no jump, so yes, this is continuous. All right. So remember, this is a repeated section. You're all getting a new score for this. I want you to be a little leery of these next two questions because some of you had some moments on the last test on these questions. So when you're solving radical equations, you don't really want anything with the radical if possible, and you definitely don't want two radicals together. So in this question, you're already set up to square both sides. And the left side's super easy to square. The square and the square root will just cancel out, so you get 25 minus 3x. But be careful, on the right side, it's x plus 1 times another x plus 1. So you need to distribute that out and get x squared plus 2x plus 1. If that's where you personally messed up last time, then you might want to consider writing it out the long way. Now, because this is now a quadratic, you're going to want to solve it through one of your quadratic methods, probably factoring. So let's go ahead and get everything to one side. This one factors real nice. So 0 equals x squared plus 5x minus 24. And we go through our factoring process. This one does factor into x plus 8 times x minus 3. So your two solutions that you're getting from this equation are x equals -8 and x equals +3. And you're like out of room, so you figure you must be done, right? But we're not, because what else do we have to worry about? Checking for extraneous solutions. So we're going to need to go back to the original problem and plug in. Let's first try -8. So you get the square root of 25, and then minus 3 times -8 would be a plus 24. Does that equal negative 8 plus 1? Well, I can already tell you that's not going to work, because how are you going to get a square root of something equaling negative 7? That does not happen in math, so this one is extraneous. 7 does not equal negative 7 is the other issue there. So let's go ahead and try x equals 3. So 25 minus 3 times 3 would be minus 9. Does that equal 3 plus 1? 16, square root of 16 equals 4? Yes, it does. So on the last test, you guys are so precious. Some of you did all that work, and then in the blank wrote 4. That's not the answer. The answer was x equals 3. 4 was the answer to you checking the solution of x equals 3. So be careful that you're writing down the correct answer. Oops. This next one I'm a little concerned about. We have a double radical situation. At least they're not on the same side, though. We're going to square both sides, and this one I'm always a little worried about you guys foiling this one out. You might want to take the step and write it, you know, as two different binomials. So, square root of x times square root of x is just x. And then you've got 5 square roots of x plus another 5 square roots of x, so you have 10 square roots of x. 5 times 5 is 25. Right side's nice and easy. Square root and squares just cancel each other out. And then, we're still kind of back in the same situation. You still have a radical. So the idea is I don't want radicals with anything if I can help it. So we're going to subtract x. Let's go ahead and also subtract 25. So you still have a 10 in front of the radical. And we've seen cases on our homework where it actually doesn't make a lot of sense to divide by that coefficient first. So don't be afraid to just go ahead and square both sides right here. In this particular problem, it didn't matter. If you divided by 10 and then squared, it's just as easy as not doing it. But I know there's at least 2 in your review worksheets where had you divided by that number, you would have had this disgusting binomial that had a fraction and then you had to FOIL it. It was gross. So we suggested that maybe you get comfortable just squaring here. So this becomes a 100, and then squaring a square root of x would just be x equals 16. Divide both sides by 100, and you get 4 over 25. And then through the art of I already did this problem, I can tell you that it checks. So there you go. You, however, will totally be checking it on your calculator, but on your paper. And guys, what happens if the only solutions you have are both extraneous, or the one you have is extraneous? What's the solution in that case? No solution, which is a solution. So don't be afraid if that ever happens. All right, here we have finally our new topics. So what I've instructed, first hour, we had a big talk about time. So this test could take somebody a large amount of time if they don't know what they're doing. And that's why your math teachers are real big sticklers on you get your 40 whatever minutes and that's what you get. Because if you don't know how to do this question and you try to explore on your calculator for 15 minutes, that just tells me you don't know what you're doing. So for the next couple sections, you actually shouldn't touch your calculator at all. In fact, the time you know when to grab your calculator is when it says graph. Then you know to grab your calculator, okay? So determine the zeros. Well, I lied. It's regression. Obviously, we're going to need our calculator there. But for this problem, we're not going to touch our calculator. Determine the zeros, including multiplicity. Describe the end behavior. Let's talk about the degree and the lead coefficient. Okay, so the first two questions that come up, what's the degree and what's the lead coefficient? For me, that tells me I should do what they call the lead term test. Let's figure out what our lead term is. So you have a 2x squared. That's also being multiplied by an x to the third power. That'll be the first term in that next quantity. And then also being multiplied by an x to the first power. So if I kind of smush all that together, I see that my lead term is a 2x to the, count them up, 6. So I don't really care what happens after that. I just want to know the first part. So the degree is the highest exponent that would have been in standard form. So for us, that would be a 6. And the lead coefficient is this positive 2 right here. When it's in factored form, it's a little more difficult to see what your lead term would be. You have to kind of work it out. So now I want to know about the zeros, including any multiplicity. So every factor, since it was in factored form, kind of gives you hints about zeros. So this first factor, 2x squared, if you were to set that equal to 0, you would get 0. But how many times does that answer show up technically? Look at the exponent. Twice. So you're going to write multiplicity 2. All right, what about the factor of x minus 2 to the third power? That's going to give me a 0 at x equals 2. You don't have to write x equals, my bad. But how many times does that show up? 3, yes, multiplicity 3. And then the last factor of x plus 1 will give you a solution at -1, and it just shows up the one time. So I just assume if you guys don't write anything about multiplicity that you just meant it to be multiplicity 1. You don't have to write multiplicity 1. Okay, end behavior. I'm asking about left and right end behavior. So you actually don't need your calculator because this is a cousin of the quadratic. So quadratics either go up, up, or down, down based on their lead coefficient. Guys, we determined this to be a positive 2 x to the 6. So is this one going up, up, or down, down? Up, up. There we go. Up, up. Very good. So we still don't need our calculator. The first question, another vocab question, is asking how do you, what are the maximum number of possible zeros, real zeros? So for that, we're just looking at the degree. So the degree of this is a 4, and then the possible number of turning points is found by taking whatever the degree is, and then taking one less than that. So I'm hearing 3 from you. Factored form. Notice it didn't say anything about like you should use your calculator. Factoring is all you. So let's look. This is a trinomial. There's no common factors, so we're going to factor it like this. They have to be x squareds in the first terms in order to work to 15x squared in the middle. And then you kind of play with the signs and the numbers. How about a -11 and -4? Now, this is still not fully factored. There's one more thing you can do for sure, and actually 2 more things you can do if you want bonus points in my heart. This one I know you know how to factor. That's x plus 2 times x minus 2. So for bonus points, again, in my heart, not the grade book. Who knows how to factor that? X plus square root of 11, good, and x minus square root of 11. So this is like my absolute favorite answer for factorization. However, if you wrote down x squared minus 11 times x plus 2 times x minus 2, they are both correct answers, but again, this is the best one in my heart. Okay. So now, the reason I like that form better is because when I go to ask you to list out all of your exact zeros, this is an easy question. You just look at all those factors, and you have negative square roots of 11, positive square roots of 11, -2, and positive 2. If you went a little lazy and you wrote plus and minus square root of 11, and plus and minus 2, that is acceptable. I like when you list them out separately, but I'll accept the plus and minus. All right. Again, nowhere does it say grab your calculator, so don't grab your calculator yet. This one. This is funny. It says that the scale is unknown. A lot of kids try to figure it out based on the graph, but like if you don't know what they're counting by on the y's, you have no way to determine this. This is my way to really get you if you don't know what you're doing on this question, I suppose. This is a mean little question. Okay, so I did give you some clues. It says there are zeros at -4, 0, and 5. So this guy right here must be the -4. This guy here is 0, and this guy here is 5. Fantastic. Okay, look at the shape. Is this an even or odd degree? Now, not symmetry, just degree. Is this even or odd? Both of the ends are going like this, so it's a cousin of the quadratic, so it must be even. I can tell the coefficient's going to be negative, but we'll come back to that. Are there any multiplicities? Are there any places on this graph where it bounces? Yeah, right here. So because of the bounce at -4, so you're going to say -4 has, let's just assume anytime it bounces for our exams, it's got multiplicity of 2. It has to be something even, and I'm not going to go crazy and make you do like 4th degree. That's crazy. This is the hard part, finding k. So your first step, and I want to see this on everyone's test tomorrow, please. I want you to set it up without knowing k first. So you're going to write y equals, I have no idea what that lead coefficient is yet. But now let's talk about all of our factors. So the first factor that we hit was -4. Or sorry, the first 0 we hit was -4. So his factor would be x plus 4. But you guys told me that it had multiplicity 2 because it bounces. So make sure you put a squared outside of that factor. Another factor that you see is that guy at 0. So you can write x minus 0 or you can just write x. I don't really care. I think for a lot of kids this feels more comfortable to just keep it looking the same. And then the last 0 is at 5, so his factor would be x minus 5. And again, that one doesn't have any multiplicity besides 1, so we don't need to do anything weird there. So this is just your setup. We're going to come back to this step at the very end of our problem, because now there's one more clue they gave me, and it was this polynomial goes through the ordered pair 1, 300. What good is that? It's super good, because that's an x and a y, huh? So that's an x, that's a y. All right, so now you go back to your setup and you plug in those values. So y is 300. I still don't know k. But now we know that x is a 1. So you're going to say 1 plus 4. Don't lose the squared, though. That's the most common mistake here, is kids lose this is squared. So 1 plus 4 squared times 1 minus 0 times 1 minus 5. So all of this stuff that's attached to the k, I think it's -100. And I'm out of room, so I'm going to move down here. So right now I have 300 equals k times -100. So one more step, guys. I think you know k. So we just found out k is -3. Great. Now you got to go back and actually give me the problem. So go back to the setup step. This time you know k, so you're going to write -3. And then everything else can look the same. So if you just wanted to write x plus 4 squared times x minus 0 times x minus 5, there's absolutely nothing wrong with that answer. In fact, I love it. You can, of course, rearrange the order. The only thing that I might see differently from a few of you is this x minus 0. A lot of you probably just called that x. So if you wrote down -3 and then times x plus 4 squared, of course, that's equivalent. So that question had a lot of work because you were trying to get k, and then once you found k, you had to go back and put it into the formula. We've done a lot of questions like that where you had to go through all the work to find k and then go back and place it in the formula. This is the only way for you to do this question, guys, so make sure you get it all that work down. Sometimes some of you have lucked out. We're like, oh, I think the k might be like a -2, and then you just throw it down hoping for the best. Well, you're going to have to show your work on how you're going to get -2, please. All right, this is on your calculator. Now, it does say in this problem to use a power function. So if you get your data into list 1 and list 2, that's where I put my data, but you can put it wherever. I'm going to pause the video so people on the internet can get their data entered. So once your data is entered into list 1 and list 2, normally what we'd have you guys do is look at the scatter plot. So in order to kind of play with the settings for the plot, you'd have to go to stat plot and turn on one of your scatter plots and then make sure it's graphing where your data is located. I kept messing up on this question when I was keying something, and I didn't realize for like 10 minutes that I had list 2 for my plot. So it was graphing like a line, which was not very exciting. But that's why I kept having trouble. So make sure you're graphing the right data set. And then when you hit zoom 9, you're going to see a graph of the scatter plot. Now on your homework, you were asked to kind of determine the best approach. And actually when I went over a first hour with this, I apparently can't read. So we just went with quadratic because we're like, you know what, that looks like a part of a parabola. And we got an answer that worked great for quadratic regression. But then someone pointed out to me at the end, they're like, hey, it said to use power. And I was like, oh, man. So in theory, we got a little different answer if we went back and used power. So I'm going to tell you a little sneak peek into your test. Quadratic regression is the way to go, okay? So you're going to be using quadratic regression on the test. But to keep consistent with whatever they wanted here, if you were to do power regression, like they wanted apparently, you would have gone down in the list and found power regression, which is right here. And it's going to give you like a baby quadratic without all the bells and whistles at the end of it. And when you go to evaluate your function, you're going to get a little different answer than what you see in my answer key. On my answer key, I'm such a rebel, I even wrote I used quadratic regression and totally ignored the power thing. So if you haven't done this yet, could you just use quadratic regression so that way we stay consistent with what we're going to test tomorrow? So again, we're ignoring the instructions completely. Make sure it's pulling your data from the right lists. And then, as always, I want you to store your regression equation in Y1. All right. So there's the equation. You're going to jot down. It doesn't say where to round, but if we're using quadratic regression, probably we want to go to like the thousandths place. So let's write down 0.042x squared minus 0.004x plus 0.043. That's using quadratic regression. And then for that final question, it says evaluate your function, figure out something about braking speed, right? What the braking distance is for the speed of the car when it's 80 miles per hour. So when you look at your graph, you need to plug in 80 somehow. Now, since you're using a graphing machine, I would suggest you make him plug in 80. You could either go to your table and go to ask mode, or you can try the trace 80 thing. Except I'm still on the scatter plot. So remember to get off the scatter plot and onto the next function. You just hit the up arrow and it goes to the next function. Then you can tell where you're at because of the top of the screen here. If you tried to type in an 80 right now, it's going to give me an invalid error thing because my window, if you look at my window, stops at 76. Come on, buddy. So it's not going to be able to go beyond 76. So I need to just extend my window a little bit larger. Let's go to 90. So now when I hit trace and then get on the curve and then hit 80, for quadratic regression, it's going to give you about 267.6 feet. If you did listen to the instructions and you used power regression, you got a close but not quite the same answer because you have a different function. So of course it's going to be a little different. But just so we're clear on the test, quadratic regression is the way to go. Got it? All right. So that was a definitely use your calculator moment. So now we're back to don't bother with your calculator anymore, guys. We're going to be using synthetic division. And you have to show me all your work because I'm testing the process of synthetic division for you. So in the box for synthetic division, remember it is the solution to your divisor. So you're going to put a -3 in that box. And then you're going to set up your coefficients in standard form order. I notice we have a quartic polynomial here, so I should have 5 coefficients when I'm done with the setup. 1, 2, 3, 4. We're missing somebody. Who are we missing? The x squared. Very good. So 3x to the 4th, 2x to the 3rd, no x squareds, -1 x's, and 65 for the constant. Now it's a series of multiply adds. So let's see. I think this remainder kind of gets a little out of control, so sorry about that. So what happens when you make up problems, Abruzzo? All right, 2 plus -9 is -7. That's a 21. -63. That's a -64. Is that a 192? Yeah. Oh, good. And then 257. Okay, so that last number you get is the remainder. So when it asks you for the quotient polynomial, what I would like you to get in the habit of doing for these kind of questions is writing out the entire quotient plus that little remainder fraction. So these coefficients belong to an x to the 3rd problem. So 3x to the 3rd minus 7x squared plus 21x minus 64. And then the remainder is still this plus 257, who's still being divided by the original divisor of x plus 3. That says 7. So I didn't really give you enough space, my bad. That is the entire quotient with the remainder fraction at the end of it. And then the final question says, is x plus, and this is a typo, I'm sorry about this, is x plus 3 a factor? Well, if you perform some form of a division, if your remainder is 0, that's how I know it's a factor. Did we get 0 for a remainder? No, we did not. And the explanation right now could just be the remainder is not 0. All right. Still no need for a calculator. So we're going to use long division. You must show me the long division technique. And my warning to you on long division is always just to make sure your terms are lined up. So like sometimes our divisor is missing one of the terms, and you have to be careful about that when you go to line everything up at the end. So set up. The good news is since your divisor is so large, we're only going to take 2 steps. All right. Here we go. 4x to the third divided by 2x squared. Ugh. I like to show this division off to the side. I just think this is a really easy place for kids to mess up, and by kids I mean me. So that's why I show it off to the side. This is a positive, squared, Raprusa. This is a positive 2x. Now you take that answer and you multiply it by your divisor. 2x times this whole divisor would be 4x to the third plus 2x squared minus 2x. Everything's lined up nicely here. We're going to subtract all your terms. Your lead term always should cancel. And then be careful here. So you have a 10x squared, and this will become a plus 5x. That last term comes down. We're out of terms, which means we're almost done. Just one more division. So 10x squared divided by 2x squared is positive 5. Repeat, 5 times the divisor. Let's see, 10x squared plus 5x minus 5. Oh yeah, that's beautiful. Look what the remainder comes out to. Nothing. So, that's good news. That means less writing for me. And when they say, what's your quotient? It's just going to be the 2x plus 5 that we found up here. What I also know, they didn't ask me this, but I also know that this quadratic is a factorization of this original polynomial. Fun times. Okay, moving on. This question. No calculator. You don't need it. But you do have to know a little bit of something about the fundamental theorem of algebra. It says you have a polynomial that has zeros at 0, positive 3, negative 3, and negative 2i. I think you secretly know one more thing. What else do you know? If negative 2i is a root, positive 2i is also a root. They come in complex conjugate pairs. So that's the first thing I write down. So now I'm supposed to go and write my polynomial. If I have zeros, I can go back to factored form pretty easily. So like this one's easy. X minus 0, or you could just write x. These aren't too bad. That would be an x plus 3 and an x minus 3. And then let's talk about this. So that would be an x plus 2i and an x minus 2i when I go back into factors. Is this a good final answer? No, because it does say with real coefficients. So like this part's okay, this part's okay, this is not okay. These are not real numbers. So this green part, since they are conjugates, if you FOIL them together, you end up with real coefficients once you FOIL those together. X times x is x squared. Minus 2ix plus 2ix are going to knock out. And then you have a minus 4i squared. Ladies and gentlemen, you know what I squared is, isn't it? Negative 1? So instead of negative 4 times negative 1, you guys would call that a plus 4. So that's what this green thing is. So as far as like a final answer, you can continue to write x minus 0. I'm okay with that. Or you can change that for an x. And then you should write x plus 3 times x minus 3. Notice I'm not FOILing anything extra back together because it says to leave it in factored form. So What I will say about that is some of you don't read instructions when you take tests, and then you're going to spend 5 minutes trying to FOIL this together. Okay. Number one, that was a waste of your time, so don't do it. And then number two, if you happen to continue on and make a mistake in your math, I can't give you credit for having the right answer at the end of it. So don't do extra work just for funsies. Do as much work as you need to do and then walk away. So this would be us walking away. List all possible rational roots. This is that rational root theorem. So you take the factors of the constant at the end there. So what are the factors of 6? 1, 2, 3, 6. And then you divide it by the factors of your lead coefficient, which should be 1 and 3. You slap a positive and negative in front of all these. So, for my kids, I'm okay if you just put a plus or minus in front of your entire list, but internet kids, if you're one of Mrs. Hoffbauer's, I think she makes you write plus or minus in front of each term, so watch out for that. Alright, here we go. If I divide them all by 1, that's boring. That's a 1, a 2, a 3, and a 6. But then if I take all these blue numbers and I divide them by 3, I get 1/3. I get 2/3. I'm not going to bother with 3/3 because that's just 1, and I'm not going to bother with 6/3 because that's just 2, and I already have those written down. So technically you just wrote down 12 different possible rational roots, both positive. Don't forget the plus or minus. That's part of the theorem, and that would be a concept mistake, guys. Plus or minus. Get it there. All right. Now it does say use a graph and division. That means get your calculator out, okay? Now, normally I would say get your calculator out, but we're running short on time here in class. So when I graphed this polynomial up here on my calculator, one thing that stood out to me was x equals -2 is a 0. So from the calculator, I look and I see that x equals -2 is a clear place where it crosses the x-axis. So now you're going to use synthetic division in order to take this cubic and knock it down to a quadratic. Once it's to a quadratic, we're going to be good enough to handle it algebraically. So -2 goes in the little synthetic division box unless you love long division, and then you can do that. By the way, if you're doing long division, you have to divide by the factor of x plus 2. But I don't think anyone likes long division more than synthetic, so I'll shut up about that. All right, 3, -4, -17, and 6. Now, if your teacher's claiming this is a 0 of the polynomial, what should your remainder be? Better be 0, otherwise I don't know what I'm doing. All right, here we go. -10. Let's see, that's a 20. That's a 3. Yep, you did well. That's a -6, so the remainder does come out to 0. So this is where some of you just love synthetic division so much, you want to keep rocking and rolling. Because technically there are 2 more rational factors and roots that you could find from your calculator. But my suggestion to you is to, once you get a quadratic, stop working with synthetic and switch over to an algebra problem. So they first want to know all the roots. So 3x squared minus 10x plus 3. If you were to find all the roots of that, you would probably try factoring, and this one does factor nicely. If it did not factor, however, I would expect you guys to probably use quadratic formula. This one factors real nice into 3x minus 1 times x minus 3. So when you solve both of those factors, you get 1/3. You get 3. Uh-oh, I was supposed to have 3 roots. Where's the third one? The -2 from my calculator assistance. Very good. So there's your 3 roots. Now this is where some kids are better than others at this next step, explaining what you did to justify all of this. Okay. For me, the explanation would be, I used my calculator and saw that it had a root at -2, and then after synthetic division, I factored the quadratic. Ta-da! For some of you, it's going to be more synthetic division based. Like maybe you saw that there was a root at -2 and +3, and maybe you did synthetic division twice, and then remained with that one linear factor. I'm going to be honest, guys, synthetic division twice and ending in a linear is kind of awkward. So I wouldn't suggest doing that. What I don't want to see is a kid who just went straight calculator. Because on this one, you technically could have, right? You could have found all 3 x-intercepts using your calculator, but they wanted you to employ some part of this theorem. So you have to do synthetic division somewhere in your problem. Now, this is where I'm really nervous for that kid who does all calculator work. A kid who saw that he has 3 zeros wrote this down. X minus 1/3, X minus 3, and X plus 2. And this is not correct. So the kid who goes to the zeros and just plunks them into factors. This is not right. Anyone catch why? They've lost their lead coefficient in that inspection step. Okay? Go back to the very beginning problem. What was the lead coefficient? There's a 3 in front of the 3x squared. So if this kid knew that, he could just stick a 3 on the end of the problem here, and that would be fine. But for me, what I do is I just go back to my quadratic factors, and I write those down, because they did not lose the coefficient. Okay? So either one of these answers is okay. I just want to be cautious. If you're the kid who just pulls the zeros and throws them back into factors, you've lost your coefficient at some point, guys. So be careful. All right, good luck.